So, good afternoon, gentlemen. So, what I'll be doing now is to show us how to model um, this network in EPANET. This is an example that has been included in the EPANET manual tutorial. So, this is a source. This is a pump. These are the nodes. This is the tank. So the idea is that water will pump from the reservoir into the network. So the first thing you do is you open your software, your EPANET software. So this is the EPANET software. If you look down here, you see that auto length is on. I'm going to click it and turn it off. The idea of the auto length being off is that the length of each pipe section have already been calculated manually. So, but if the auto length is on, it means as I'm drawing any pipe length, the system is capturing the length real time. But I don't need that because the design has already been done. This design has already been done for me, and already the node variables are here, pipe variables are here. So I will turn the auto length off so that I can manually impute the length of each pipe section. So the first thing I do is in my AutoCAD, I'll go to project, I'll go to default. When I go to default, I will say, let my every junction be N, for instance, reservoir should be reservoir, tank should be tank, and then let my pipe, okay, let's just say let my pipe just be one. Let me name them 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So here, I'll just make sure that the increment is set at 1, so that it will be pipe 1, pipe 2, pipe 3, pipe 4, and so on and so forth. The next thing I do is I go to set my properties. I go to hydraulics and I'll check the unit and say I'm doing it in gallons per minute because that's the unit tutorial came with. It's the American unit. The head loss formulas, I'll leave it as 100. The maximum trial, I can leave it to 0.1 or I can say 0.01. Okay, it just depends on what you want. If you input any value, you tap enter. Then under properties, the pipe diameter, since I'm drawing in imperial units, I would say that if I fail to, the default pipe diameter should be like, let's say 6 inches, 6 inches pipe. Okay, that's 150 mm. So let's say 6 inches pipe. And the roughness, since I'm using a PVC pipe, he said we should do the roughness of 100. So let me put the roughness of 100. So these are the default parameters. So I will say okay. Okay. So if you look down here, you see that my unit have changed to GPM, gallons per minute, which is an empirical American unit. And the auto length is also off. So what do? I'll come here and I'll pick the reservoir and I'll drop it. And the reservoir looks so small for me. If I want it to increase it, I will first of all pick this select tool. I will now go to view. I'll go to options. I want to increase the size. So the node, I want the node to be 5, to be bigger in size. I want the link to be like 2. Okay. For the notation, I want him to display the node ID, the link ID, and also maybe the display this link value. Let me leave the link value out. Leave out the node value. Let me only display the node ID and the link ID. So the number will appear on those nodes. I'll click OK. So you can see it's now saying res 1, reservoir 1. So the next thing I'm going to do, I'm going to add all the nodes. So I have another node here. This is node 1. Remember, this is what I'm trying to duplicate. This is the drawing I want to duplicate. You can see where the nodes are. Good. So I'll drop one here. 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 And I'll click this black arrow. I'll now go and pick the tank. As I'm doing, just be watching your diagram, okay? And you see that it's exactly what you will get. And this is what we're trying to draw. Generally, this is it. So after I've drawn the node, the next thing I will draw the pipes. So I'll click on pipes. I'll click on this pipe and I'll click on here. Once it does like this, you know that, okay, it's okay. I'll click again, it will turn to a pencil. I'll click at the middle, it will go off. But the command will still be active. So if I finish drawing, I'll just go and click this select symbol, but I've not finished drawing. So the next thing I need to do is to draw this other one. So I'll just connect all the nodes. I'll connect all the nodes. Okay. Now, the first node you saw here is not a pipe. This is a pump. From node 1 to node 2 is a pump. So how do you pick a pump? I'll just come here. I'll drop this one. I'll pick a pump. And I'll draw here and draw to node 1, and the pump will appear. Please take note. This is how the pump is drawn. So this is the network. I've drawn the network. Now, this shape here, now I'll go and drop it. Drop that. This shape here, you can see this is a curvature. It has a small curvature here. So to draw that curvature, I'll make use of the vertex. I'll click on the vertex. I'll come here and click on pipe 7. I'll right click. I'll say add vertex. I'll right click again. I'll say add vertex. It will add some vertex for me. To add it has 3 vertexes. I'll click again and then add the 4th one. I will now click on each vertex. I will hold it down and drag. I'll click on each vertices. I'll hold it on and I'll drag. I'll click on that vertices. I'll hold it on and drag. I'll click on another vertex. I'll hold it on and drag. So this might look small, but this is how this is called digitization. So I'm able to digitize the system based on the map I have. Remember yesterday we were able to have a background map. With the background map, you can now draw your network, just a representative of your network. The same thing you have designed, the same layout you have done. You just draw it in form of a network. Because after drawing that in form of a network, you now start to impute the value. So I'm going to give you the opportunity to draw this network now, then we'll continue. Thank you.
Hello, sir.
Okay, yes.
I was trying to.
So this is the network. We have finished drawing the network. The next thing we need to do now is to impute the 4 variables that you need to make this model work. Every model has what we call boundary conditions, and we have variables. So 2 variables for the node, 2 variables for the links. So let's start with all the nodes. So for the reservoir, I will double click on the reservoir. The property window will open. I'll go to the head and I'll impute 700 and I'll press enter. That's all I need to do. Because in this manual, you can see that node 1 has elevation of 100 and node 1 happens to be the reservoir. And the demand there is 0, of course, the demand is 0. The next one, I'll go to node 2 and the elevation of node 2 is 700. Node 3 elevation is 710. So where's my node 2? So this is second node, even though it's written node 1, the elevation is what? 700. And the base demand is 0. And I'll press enter. So where's the location of node 3? This is node 3. And how is node 3 located? This is node 3. Node 3 is here. Look at node 3 here. So this is node 3 here. Here with me, this is node 3. So in my drawing, I think my drawing is faulty. My drawing is a bit faulty. So let me quickly prepare it. So I'll click here. I'll click on this pump. I'll delete it. Then I'll create another node. I'll put another node here. Then I'll click on this black arrow. I'll click on this reservoir. I'll hold it down and move it. I'll hold it here and I'll move it here. Then I'll create a new pipe from this. Don't mind the lettering. Later I'll show you how to change the lettering. And I'll click on the pump and I will click here. So this is, I'm back to the network. So let's start all over again in imputing the value. The elevation has been imputed. Node 1 is, the elevation is 700 and the demand is 0. Okay. Then I'll go to node 3. This is the node 3 now. Later I can change it. The elevation is 710. And the base demand, what's the base demand again? This particular node, I'm talking about this node. The base demand is 150. So that's where houses start popping up. So I'll click again. The base demand is 150 gallons per minute. Enter. So if I'll be imputing these two variables in all the nodes and in all the pipes also, but we're starting with the node. So node 4, 150, node 5, 600. So all I need to do is just to write it down somewhere, if possible. I'll just write it down somewhere, like in a piece of paper, and then I will be imputing them one after the other. So let me just hold on. Okay, let's go. So these are this. So I'll just come here to my EPANET drawing. So this is this. Elevation is 710. The base demand is 200. Enter. I'll come down here. The elevation is 650. The demand is 150. This one, the elevation is 700. The demand is 200, I guess. So node 7 is 700 and 0. Node 8, which is the tank, is 830. Take note, this is node 8, 830. So I'll come here. The elevation here is 700 and the base demand is 0. I'll enter it. Now, why this dialog on is on? Look at this place. This is junction N2. I can just click on the tank. Once I click on the tank, it automatically change to tank TK. So I might not even have to close it. I'll just click on the next item. The dialog box will automatically coordinate. The elevation is 830. And there are some value for, this is like a tank design. So there's some value for the tanks. But all I know is that just leave it the way it is now. If you want to see the value for the tanks, you can go down at the page 4. Yeah. For the page 4, here, look at how you impute. Say for the tank node 8, enter 830 for its elevation, 4 for its initial level, 20 for its maximum value, and 60 for its diameter. So it's more like just design the pump. So here you say I should impute, here is 4. Minimum level, I can leave it at 2. Then the diameter will be at 60. I think that's all for now. So just to review all we have done, I will click here. You can see here the two values have been imputed, elevation and base demand. All the nodes, I'm interested in all their elevation. So while this dialog was on, I'll just be clicking on each of them and I'll be seeing the values I've imputed for the base demand and for the elevation. So anyone that is not there, I will know, okay, there's a problem with it. So I have finished imputing the values for the elevation. I will now quickly go to the pipe parameters, the other two pipe parameters. And those two parameters is also in page 4 of the manual. And you can see that the diameter varies from 14 to 6. The minimum diameter of the pipe is 6, the maximum is 14. And the node 1 and node 2 have length of 3,014 inch diameter. This is in inches, of course. And node 2 and the pipe 2 has 5,000 length and 12-inch diameter. So where is 1 and 2? This is 1 and 2 here. This is number 1 here. So this diameter from this section to this section is 14, and from this section to this section is 12. Okay, so please take note of this. It's very, very important. So now we are finished imputing the variables. So for this first line, we'll scroll up. The length is 3,000 and the diameter is 14 inches. This is it from the table. look at it. Number one, this number one and number two and number six. Okay, let's say number one, number two, number six. What are they? So that we can see. So number one is length is 3,000, the diameter is 14 meters, 14 inches. Number two is 5,000 feet. Sorry, this is in feet, this is American unit. And the diameter is 12 inches. Then number six is 10 inches. Now, if you look very well, you see what we've been discussing, that the diameter in this stretch from the reservoir to the tank, as it's going forward, is varying. Why? Because at point one, it's serving the whole network. So the pipe diameter at this point is 14 inches. But once it crosses this place, it has delivered water to this link or this tributary. Let me use the word tributary. And then the pipe automatically reduces to 12. Then when it passes here again, the pipe automatically reduces to what? To 10. Because now the consumers in this area have taken some water off the system. So let's continue in imputing these values. So I'll just double click on this one again, and the length is about 5 meters, and the diameter is of course 12. I'll just press enter. The roughness is there already because I imputed the roughness as default. Then I'll go to pipe 6. Pipe 6 I think is about 7 meters, and the diameter is 10 inches. Okay, so what is pipe 3, 7, and 8? 3, 7, and 8. 3 is, okay, sorry, pipe, not node. So pipe 3 is 8 inches, 7 is 6 inches, 8 is 6 inches. Their length is 5 meters and 7 meters respectively, just like that. So I'll come back here. Okay, so the length is here is 5 meters, and this is 8. This one is 6 and is 7 meters. And this one is 6 and it's 5 meters. And this one is another 5 feet, 5,000 feet, sorry. And I think it should be 8. And this one is another 8 inches and is about 7 feet. 7,000 feet. And how about this? I've imputed it. So I can move around all the pipes. You can see all the pipes all have two variables now. They have length and they have diameter. All of them have length and they have diameter. So that means I have finished designing the pipe and the node. So the next thing I'm going to design now is the pump. So but before I design the pump, let me just give it. So after imputing all the variables, the next thing I will do is to design the pump. Now, the pump, how to design a pump is every pump has what they call pump head. Okay, every pump must have a flow and a head. So if you look at the table we have, you'll find out that in the elevation, you find out that the highest elevation we have here at the reservoir is 700. And the lowest elevation we have in this network is 700. And that is where the reservoir is. And that is where maybe the stream is. Or that's where the position of the groundwater. And the highest elevation we have is 830. So it means you need a pump because the tank is located at 830 meters above sea level, while the reservoir and the intake structure or the treatment plant is located at 700. So if you say 700 minus 830, that will give you 130. It means that we need a pump that will give us a minimum head of 130 feet. That is how to size a pump. But because of frictions and other losses, we'll decide to make it 150. So the difference between the two heads will give you an idea of what the pump will need to overcome. Then if you look at the flow we have here, we have about 200 flow. So our flow, we should provide a flow that is more than 200. So by the time you add one or two of this flow, you'll be getting something like 600. So we're going to design a pump that can overcome gravity to deliver water to this tank. So when we go to our EPANET drawing, how to do a pump is, number one, you design a pump curve That is all. You design a pump curve and you link it to this pump. So what do I do? If you double click on this pump property, you will find out that these are the properties of the pump. The value is pump 8. And pump curve is 0. There is no value for the pump curve. So to size a pump or to buy a pump, there are 3 variables you can use to buy a pump. Either you use the head of the pump and the flow as a parameter to size a pump, or you use the power requirement to size a pump, or you use the rotational speed to size a pump. So it's either use the power, the rotational speed, or use the combination of the head and the flow rate. A combination of the head and the flow rate is known as the pump curve, which is the operational curve of the pump. So to make it easy, the easiest one in the market to size a pump is to use the head and the flow. What discharge do you want the pump to discharge? And what head do you want it to overcome? Those are the 2 basic parameters to size a pump and get it right. So, but if you look at this property of this pump, it does not have a pump curve. So what do? We go to here, to our data browser, scroll down, and go to where you have curves. You see it's blank. There's no curve. If you look at this small icon here, if you hover around it, it will say add. So I'll click on it. I need to add pump 1 for me. I need to bring up a dialog window, and the pump ID is 1. I'll come under flow here. I will say 600. I'll come under head. I will say 150. Why am I saying 150? Because the difference in the highest point and lowest point in my network is already 130. So I'll just add extra 20 to serve as factor of safety to take care of frictional horizontal pipe friction, because that 130 is the difference in height, which is what we call the geodetic height difference. But we know that losses in a pipe network is a function of 3 parameters I told us yesterday. One is the geodetic difference, is a head that needs to be overcome. The next one is the frictional factor in the pipe. The friction in the pipe is another thing that needs to be overcome. And the last one, which is not often mentioned, is the velocity of flow. There's a friction due to velocity of flow. There's a friction due to pipe body, which is a K factor due to pipe roughness. And then there's friction due to overcoming gravity. So when you do this, you can click anywhere down, it will bring you the curve. So this is the pump curve, and it will also bring equation of that pump curve. So these are pump curve. The flow, this is all the flow. So you can see as the flow is increasing, the head is going down. Those of us that are conversant with pumps, submersible pumps, as you have a higher head, lower flow rate. Lower flow rate, higher head. Then remember, take note of this 1. The curve ID is what? 1. So I'll click OK. So I'll go back to this pump and double click. Under pump curve, I'll type 1. So I have been able to link that pump curve and this pump. So remember what I did again. Let me redo what I did again. What I did again was to go here. I go to curve. I click add. And I'll leave it at pump 2 because I've already created the pump. I'm going to delete it just for demonstration. I type 600 and I type 150. And I make sure that 1 is here. Okay. And then this is the curve. Then I click, but in this case, I'll just click cancel. I don't need to create it. And here, I'll delete it. I'll click on this middle one and delete it because we don't need it. So we've already created this one. And because I've created this one, if you want to edit it, you simply click this icon, edit. And this is called the pump we created. The ID is 1. Click OK. So I have only 1 pump curve and I have only 1 pump in my system. If I click the pump again, I will see that the curve is not 1. So after doing this, I will now know that I've imputed all the variables in my network. To make sure that everything is okay and nothing is wrong, I will come here under report. No, sorry, under okay, under project,
Sorry,
I'll say run analysis.
I have a question.
So now that I've imputed these values, the next thing I'll need to do is to run my analysis. So I'll come here, either I go to project, run analysis, or I go to this symbol here and say run. So when I say run, it is to tell me that my run is successful. I'll click OK. So this is what we call static run. It's just day one by 12 a.m. This is the run. To view the results of what I have done, I'll go to map view. Map, here you see data. This is data view, this is map view. When you go to the node, I want to see the elevation at the node, and I want to see the link, I want to see the velocity. So to bring out the velocity and to bring out the node. If I want to see more variables, that means I have to go to my view. I'll go to options. I'll make sure I'll go to notation, and I'll click, make sure that these 4 variables are highlighted. I'll click OK. So the value will now display to me the velocity, and you also give me a legend, which I can play around with. So you can see that this is how you can design this simple network, okay, and then run a static analysis, a 1 hour static analysis of what you have designed. So once again, you draw the network, you impute the node parameters, you impute the pipe parameters, you design the pump, you design the tank, then you run your analysis, and that is how it is done.